guys, welcome back. Today is 14th. Um, Today is a big day. We have the Jane Street interview coming up today in around 6 hours. So that gives me around 6 hours to finalize everything I do. Nice one that I wanted to try again yesterday was the design insert, delete, get random in all one space. I think this was a pretty good design question. So we're going to implement a randomized set class. Initialize randomized set. Inserts a value into the set if not present. And true if it can be, false otherwise, removes the item. And this in getrandom returns a random element from the current set of elements, where each element must have the same probability of being returned. You must implement the functions of the class such that each function works in average O1 time complexity. So insert must be done in O1. This instantly tells me that, well, the remove O1 tells me that we might need to use a hash map or hash set of some sort. Because let's say we have an array and we want to remove the middle element. By using a normal array, we can't do this in O of 1. A linked list would also not work as we have to traverse through everything. But then the thing is with a hash set or hash map, does not have random access memory, such as what we need to use the getrandom function. So first things first, we need to initialize a store and an array. This store will have the key would be the value, and the value will be the index in array. So let's try it. So if value in store return false, else we're going to create a new entry in our store with the length of the array, which this will be the array this will be the index that it gets placed in. I'm going to append to the end of the array of the value. Return true. Now for the remove part, this is the hard part in the remove part, because let's say we have an array, and if I pop from the middle of the array, then everything on the right of it will be shifted towards the left. Now that's completely fine, but now the problem is that these indices getting stored in the store will be pointing to the wrong place. Let's say, for example, I have an array of O and 1, O1, and then I pop O, so I only have 1 left. But the store value in store for 1 will still be 1, and this will be called an index out of bounds error. So the problem only actually realizes for everything on the right of the node that we want to delete. So what each thing we can do is we can move the node that we want to delete to the very right of our array, because then there will be no shifting happening. So first we need to check if val not in self.store, we need to return false. But if it is, we're going to get the last element. Right, we'll first get the index of the thing that we wish to delete. Then we'll get the last element. Array -1. Then we're going to swap it. So self.array index is now going to equal the last element. Self.store value is now going to equal this index. Yeah, now we can simply pop. We can pop from the end and delete the mapping for this value. Return true. For this, we can simply return random dot choice of anything within the array. Whoops, pen only has 2 P's. Wait, so insert 1, remove 2, insert 2. Yeah, so it's random, so this is random. It's going to be either or. Apparently not, let's see. is not what I want to do. Yeah, we want to update the last elements to the new index. Yeah, there we go. Cool.